Um, well, you have all these dot files and configurations. SSH uses an entire directory full of configurations, .ssh. We're going to see some other things. Git has its own configuration, git config. They're new enough they didn't copy the RC. They actually use a reasonable name calling it git config. I would have generally some caution in changing these files. I mean, especially, caution in things like changing my vimrc because I can make it so I can't edit files easily. Changing my git config and losing some piece of information in there that I really have to have, like authentication keys so that I can work on a particular project. So there are things in here you really don't want to lose. So before I go and edit any of these, I have a .back directory that I tend to copy them to, so that if I goof up badly, I can recover what my previous version was. And the second thing is I actually store all of these things in a single .files directory in my home directory. And the .files directory is actually a Git repository. Remember I said, you don't push these things up to GitHub and then announce to the world, here's all my passwords. So I treat this differently than all my other Git repositories. There is actually a project that Mozilla has done for key authentication called SOPS, and I've provided you a link there, that I use to protect this, that provides strong encryption for a bunch of this data, so that I can actually use it in Git and have the at-rest data encrypted, so that I don't have my passwords exposed inside these files at all. And that means I have better safety, but SOPS also has all sorts of capabilities for organizations to keep track of entire sets of organizational passwords. It's an awesome program. There are some others out there that are doing this, but this is a really nice way of tracking all sorts of authentication and passwords. So I do use it I do keep this stuff in Git so that I can keep versions and I can see how I had it before. But again, I'm kind of careful with those things, and the actual Git repository that I use for my .files is not GitHub or a public repository. I actually have a private Git that I use that is only used for this, and I still encrypt everything going into it so that it's not available to the public. Now, how do I make those things work with Git? I said, in your home directory, you've got .vimrc, but, oh no, actually I've stored the file over here in some other location. Unix provides a nice thing called symbolic links and hard links, and this is unlike Windows. If you're using the Windows system, the Linux subsystem on Windows, they have managed to emulate this effectively, sort of, mostly effectively. But otherwise on Windows, you just don't have this facility. You just can't do it. And Windows has a link facility that is something entirely different that has to do with their user interface and isn't like Unix links at all. So let's go through an example with links and take a look at what they can do. First of all, there's two kinds. There's hard links. That's the one I'm going to show you first. And then we're going to talk about symbolic links. So hard links, the way that the Unix file system works is a directory is a list of file names with these things called inode numbers. And an inode number is the actual location where the data is stored. So, and it's a big number, is all it is. Each disk volume has some number of inodes on it. 2 billion, depending on the disk, 20 billion on a bigger disk, something like that. But these tables of inodes are where the actual data is stored for the file. Now, the file names themselves are just a name with this number. And since it's just a name with this number, you could have more than one name that has the same number. And the way you create these is links. So let's say that we create a file named Bob. Okay, so we'll just go in here and let's just vi bob. Okay, and we'll save it. Now if I do ls minus li on bob, you'll notice that I've added this extra option I to show the inode number. And over here we have this big long number that is the inode for bob. Now, okay, so we can see the inode. There's not much we can do with it until we do ln. We do ln of bob to Jane. Now if I do ls minus li of the entire directory, you'll see a couple things here. First of all, there's Bob, and by golly, his unique identification, his inode number is that. But now we also have this other file, Jane, and it has the exact same inode number. And this thing that used to be 1 in this column, which is the count of the number of inodes, is now 2. Now, what Unix does with this is it'll let you put these anywhere you want on a file system. And you can have, as far as I know, as many different file names as you want for a single file. And when the number of references for that file goes to 0, it reclaims the storage. Until that point, it doesn't duplicate the storage, it's just a name with a number. So I can change these just as I would otherwise. I can say move Jane to Jane 2. And it's still the same inode number. All I did is just change the file name. And this is really useful for a lot of things. For instance, I have directories of images on my system. And some of those images I want to group together. Instead of duplicating the images which are big, I just create a new grouping and I just link all the ones that I want in that grouping in there. And all I've done is created new file names, but I haven't duplicated any of the storage. So there's lots of uses. You can't do hard links to directories, at least not by default. And if you do, it is very dangerous and you have to be root and it can break lots of things. So usually it's only for files, just the in the file system. And it does not confer any difference in terms of things like the permissions. If you change the permissions, it's not changed on the file name. All of the permissions and ownership and access dates and modification dates are all associated with the file itself, which is the inode. So changing permissions applies to all of them, which is kind of an odd thing if they're in different directories, but that's the way that works. And you can't do it across file systems. So it's just within a single file system that these inode numbers exist. But it's really useful for lots of stuff. This also explains why the original name of the Unix remove command was unlink. Because what it did is it took away one link to a file, that's one inode, and when you got to 0 inodes, the file went away. Another thing that references a file is if you have it open in a program. And this happens pretty often where you run a program and the program wants to have a temporary file. So it goes and creates the file and then opens it. And it's doing fun things, reading and writing to that file, but it wants to guarantee that no matter what happens at the end of execution, the file goes away. So what it does is it unlinks it from the file system. Now it's still open, and that openness of the file at runtime counts as one reference, so it doesn't delete the file off of the disk, but now it has 0 file names on the disk. And when the program ends, the one reference of it being open goes to 0, and the operating system reclaims the storage. And usually this works pretty well, but there is the case when something goes wrong with the program and it's writing all sorts of storage out, and you as the system administrator can't find the file because it doesn't have any file name, and you're going, why is all my storage being eaten up? I can see all my storage is going away, but there are no files in which this exists. And you have to remember that, yes, you can have files with 0 file names, but a program is running, writing to it. And there are tools like LSOF to list the open files so that you can see which programs are writing and how much, and you can go find the offending program and zap it. Or kill it, or you can reboot the system, which will kill all the programs and anything that was open goes away. So there are good and bad sides to it, but generally speaking, it works pretty good. The nice thing about having a file that you've deleted the name is for a temporary file, nobody else can open it except the program that currently has it open, and it kind of becomes a private temporary file. So things like databases use this pretty frequently for things like they need to have temporary files where they're sorting a bunch of data to it, and they're reading data from their normal tables and creating this temporary storage to sort data, and they want to have that file, but nobody else needs to see it, and when they're done, they simply close the file and the data space is reclaimed. So there are lots of good uses for this. Now that's hard links, and those are based on inodes. Windows doesn't have inodes, and its file names are associated with the file, so it's not a reference, so you can't have multiple file names pointing to the same file. You know, it's a more primitive operating system. And then you get to symbolic links, and symbolic links are used by lots of stuff. Let's create one and see what it looks like. If instead of last time I did ln, let's do ln minus s to say it's a symbolic link. And we'll create one called Tim2 to Bob. And I did that in the wrong order. It's from the file that exists to the new link. And now when I do ls minus l, you'll see that I have a file named Tim2, and it says it's got this little arrow right here that says it's a symbolic link to the thing named Bob. Now, symbolic links are resolved by the file system saying, oh, this is a symbolic link. It's a special kind of file over here. You'll notice it says L there instead of minus or D. And whenever I see this, I take its destination, Bob, and I just replace that and I continue processing. Now, I can create symbolic links that don't reference any file at all. Let's create one between A, B, C, and D, E, F. There is no file there. If I type in the right thing, ln minus s, okay, and then I do it, and you'll notice that, yeah, when ls goes out and reads it, it looks at these symbolic links and it says, this DEF symbolic link you have here doesn't point to a file, so I'm going to mark it in red because it's like broken. You don't have to have symbolic links that are just one level deep, and they can span file systems, and they can do all sorts of other stuff, but one of those things is we could create the file ABC. Now when I do ls minus l, it says, oh, DEF actually points at something finally. Okay, so you can create the symbolic links for things before you have the files. You can remove the underlying file, and it doesn't remove the symbolic link. That's both good and bad, I suppose. You can have symbolic links that point up in a directory tree, and they can point to directories. So we can do ln minus s. I can do this, and I can do it to the current directory. And now I have created a symbolic link so that I have access to this file that's 2 levels up in the directory tree in my current directory. This is all good and fine, okay? But if you're following symbolic links and they can point at other symbolic links and they can point at other symbolic links, it's also possible to create loops. And some programs that don't check for loops correctly will get very mad if you create loops in your symbolic links. You can have symbolic links to entire directories that are loops. And again, programs that don't check it correctly, and it is complicated to check, will get broken by these kind of links. So there is some judiciousness that you may want to use in creating these things. However, at the same time, if you go and look in my home directory, I'll do ls minus l of vimrc, you will see that, yes, my vimrc is actually a symbolic link at this other location in .files. And I have pretty much all of my dot files are done that way. That way, dot files is my Git repository, and I just have symbolic links in there. This makes it easy to port my dot files to a new system. I just grab this entire directory of stuff and ship it over, and then create symbolic links. There, I actually have a script that will go through my dot files directory and automatically create symbolic links for all of them on a new system. So it's quick to port, and I get some benefit from having it.